All right, so if you can take a quick look at the list of numbers, you can spot out a few things. I think it's extremely easy to spot out what the A1 is. A1 is 6, of course. That's no-brainer. And it shouldn't take you much attention to spot out the R value. In this case, the R value would be a -1/2. So we are almost ready to write our segment notation, except that we need to know one thing, and that is, hey, what is the N value for this guy right here? -3/256. What is this? Now, just do a little guessing here. What do you think? The N value here, would it be a odd number or even number? It will be odd or even? What do you say, odd? Just guessing? Was it even? Just guessing? We can do better than just guessing. It has to be even because if you look at the pattern, again, pattern. We're humans. We're good at looking at patterns. The first term is positive. The second term is negative. The third term is positive. The fourth term is negative. So the N here that we don't know, that we're searching, it must be an even number. But what even number? We don't know. We want to find out. Okay. So so we'll see. We'll see what it is. Now, if you have a calculator, if you are just a little curious about what that is, you might do something like this. You might say, all right, I know the A1, I know the R, and I know it's going to be an even number. I'm just going to go ahead and take a random guess what the even number is. Maybe 6, maybe 8. Let's just say, is it like 6 or 8? 8? All right, let's see if it's 3/256 negative. Almost. So let's just cheat a little bit. Okay, so we say it's not 8, so in this case it should be 10. Wait, hold on. That is strange. 3/256 negative. Wait, hold on. Oh, you know what? I forgot the little n-1. That's why things are going off a little bit. It should be -1/2, and then the raised to the power of well, in this case would be 10 minus 1. The n is 10 in this case. So we cheated, and we know the answer, and it's equal to 10. But now, if we don't guess, can we find out how it is 10? Well, you have this situation, okay? And to make things easier, we'll say, all right, let's go ahead and multiply 1/6 on both sides so that you can cross out the 6. So on the right, you only have -1/2 raised to the n-1 power. And then you can simplify this. You get -1/512. Okay, so far so good. So now we're asking the question, all right, so 1/2, -1/2 to the n-1 power, what would it be? Now, so now I'm going to also throw in an additional question, and that is, can we ignore the negative sign right here? Can we ignore the negative sign right here? Meaning that, can we just go ahead and say this? Okay, can we just go ahead and say this? Why yes, or why no? At the end, it will even out, yes. Or the way I would put it in a more straightforward way is that we knew something. What do we know? We know n's could be an even number. And that means n minus 1 would be an odd number. So the number on the right will end up to be negative, eventually. And the negative on the right-hand side will eventually cancel out with the negative on the left-hand side. So we can kind of move ahead and say, all right, those two negatives, they cancel each other out because we knew something, right? If you don't know that piece of information, you cannot ignore the negative sign. But we could ignore the negative sign because we knew that n is going to be an even number, n minus 1 would be an odd number. And if you have a negative number raised to an odd number, it would remain negative, so it stays there. So now the question is, well, 512 could be expressed as 1/2 to the what power? Okay, so I'm going to say, let's go ahead and take a quick guess and say 1/2 to the 10th power. Nope, not the 10th power. 1/2 to the 9th power. Yes, 1/2 to the 9th power, it's 512. So that is the case. And we say, well, 1/2 to the 9th power, it's equal to 1/2 to the n minus 1 power. So that means n minus 1 is equal to 9. So n must equal to 10, which we knew at the very beginning. We guessed at it, but we want to make sure that you know how to find it using good fundamental math. So we say n is equal to 10 for this case, and therefore we would write our summation notation. We'll say, all right, please go ahead. We add the first term all the way to the 10th term. And what's the notation here? Well, it's a geometric series. Geometric sequence here. So we have A1, which is 6 times 1 minus, and then negative 1/2 raised to the 10th power. And then a lot of parentheses going on here. So make sure you don't lose track of the parentheses. And then 1 minus negative 12. And then close parentheses. All right, so make sure you have all these parentheses. And the way I would do it to keep the parentheses organized is that you have these subtle differences in terms of the magnitude of the parentheses so that you can see it better. Okay, so if you have to compute it, then I would just say either you just type the whole thing in, or you make modifications. You do some simplifications that's done based on your knowledge. Now, I've seen this yesterday from a student. So this particular student, he is very motivated to make things easier. So instead of writing this, what did he write? He went ahead and combined the signs together. So he's trying to go above and beyond to make things nicer. And I would say, yes, but not for your first step. What you should do for your first step? Just substitute. Use the formula, just substitute, and there you go. Okay? So don't do anything extra for your very first step. You may continue to modify it for your second step, but for the first step, just insert the numbers, and that's it. Don't make it more complicated than it already is. Good.